All right, hi, Cade. Easier lesson today. Here we go. All right, so if I want to add polynomials, what do? Combine like terms. So 3x squared and 5x squared. And since we're adding, we do nothing to the exponents. Minus, yep, negative 8x, so minus 8x. Minus 14. So when you see your assignment today, realize some of them are like that. They go pretty quick. What if I'm multiplying? What do? Sure, FOIL is a word that people use. We're just going to say we're going to distribute each term to each term. Yeah. If you're asked to factor, then that's what you'll do. But you're not asked to factor. So that's what a lot of people want to do every year, because you guys kind of come from that second semester last year. You see it, you're like, okay, what's common factor? But we're not factoring. You're right, we can take a 2 out, but that's not going to help us. We just want to multiply everything through. So 8x squared plus 28x. After I'm done with the 4, I move to the negative 2. Negative 2 times 2x, negative 4x, and negative 2 times 7, minus 14. So there I have the expression. What do now? Combine like terms. Very good. 8x squared plus 24x minus 14. So, I mean, that, we know how to do those problems, right? I'm not going to give you 50 of them to do tonight because you do 2 of them and you're good. How about C? First, I distribute the 3. What do I distribute in the second one? Negative 4. When you see the subtraction sign up front, make sure you distribute the negative as well. So this will start off as, what is my first polynomial going to be? Good. And what's my second polynomial? Negative 16x squared. Good, plus 20x. Minus 4. Beautiful. Combine like terms. Negative 22x squared. Got those. I cross them off because I'm organized. No, seriously, this is the most organized you'll ever see in my room. It just goes downhill. Some of the teachers make fun of me for how disorganized I am. There are teachers who are really organized and are right around me. So, E, what if I have, we'll get to D in a second. What about E, 3x minus 4 quantity squared? I could just rewrite this as 9x squared plus 16, right? Why? The definition of squaring something, very good, is that you take it, you multiply it by itself, so therefore I must multiply it by itself. And so I will continue to multiply through and distribute. As you multiply all those terms through, combine your like terms, 9x squared minus 24x plus 16. Quick see if you do F on your own. Go do F. Is that what you got? Good. Just make sure you distribute your negative, you'll be all right. Question. If, well, let's say it was negative 2x to the third, okay, and you're multiplying by 5x squared times 10y to the third, okay? So those are in parentheses as well, right? So the difference is that you have addition, subtraction, so you just divide those up. But yeah, since the operation is multiplication, you would add those exponents. The difference is just make sure if you were to do a problem like this, that doesn't mean you multiply the 2 by the 5 and the 2 by the 10. When it's multiplication, you don't have to do that. It's when you have addition that you put it through to each one. Okay? Now, the problem that generally people get incorrect is a problem like D. And I promise you have one on your test like this, and you have some in your homework like this. So let's make sure we get it, and you ask questions if you have anything you need to look at. So, why do you think people generally struggle with D? Radicals and fractions. So let's make the problem easier, okay? I have x to the 3 halves, and let's get rid of all the radicals. Let's turn them into fractional exponents. Instead of 2 square roots of x, how could I write that? Good. I heard somebody say 2x to the 1 half. You're absolutely right. And then minus 3 square roots of x to the 5th. Oh boy. Good. Lots of you got that. 3x to the 5 halves. Very good. So you saw that the index is 2. I'm taking the square root, second root, and so that goes in the denominator. So now that you've rewritten it, now treat it just like your other problems. Let's distribute through. You're going to have 2x to the something minus 3x to the something. What do we do with the exponents? We add them. Since we're multiplying, we add the exponents, which gives you, right? 3 halves plus 1 half is 4 halves, which is 2. And then 8 halves, which is 4. Now, my good friends in here, many of you would say, well, Mr. Gens, why not just now take out an x squared, and then you'll have 2 minus 3x squared. Is that not better? Did it ever tell me to factor? No, so don't do it. You just undid what you just had done. I know that this problem factors back to this if I want to. So don't try to, go further than what you're asked. Yes. Oh, to get from 3 halves, 5 halves to 4, you add it. 3 halves plus 5 halves is 8 halves, which reduces to 4. It's a good question. Thank you for asking. I didn't write it down. Okay. All right. Let's actually do what you want to do then, which is you want to factor. We'll try some basic problems. This will move by pretty quick. Greatest common factor. What's the greatest common factor that exists between 4x to the third and 6x squared? 2x squared. I take that and I put it out in front. Okay. When you take it out, you divide the remaining monomials by your factor, and you come up with 2x minus 3. Done and done. If you want to check your answer, distribute it through. Make sure you end up with what's on top, and you'll be good. Do the second one on your own. Either or is okay, right? This is descending order of exponents. This is not. I would still accept it. What do you think is a mistake people make when they do that problem? Forget the 1. Make sure you remember the 1. 1 is super important, okay? Got to have it. Trinomial with lead coefficient of a equals 1. That'll be if you have ax squared plus bx plus c, and what you do is you have a lead coefficient of 1. Okay? So this is an example where a front coefficient is 1. These trinomials are easy to factor. We know they factor to 2 binomials. So we have x and x, then we simply need to find the 2 numbers that multiply to negative 33 but add a negative 8. What are they? Negative 11 and positive 3. Do the second one on your own. Should have x minus 16, x plus 3. Could you also have x plus 3 times x minus 16? Yes, because multiplication is commutative. Could you have x plus 16 times x minus 3? No, because that would give you a positive 13x in the middle. Question? So you have a 1 in front of the x squared. And that makes it an easy trinomial, as opposed to this. Does that make sense now? So this is a lead coefficient of a not equal to negative 1, or not equal to 1. Okay, so this is different now. Now there's, when you have a trinomial where the front coefficient isn't 1, then you need to either factor by guess and check or by using the AC method. Now, who remembers the AC method? Okay, raise your hand if you don't know what the AC method maybe is. I didn't know when I came here. Okay. So, if we want to factor this, we need to find factors of 8x squared first. What are those factors? 2x and 4x, 8x and 1x. What are factors of 3? 1 and 3. So when you set up your your two binomials, you get to choose whether you want to use the 2x and the 4x or the 8x and the x. We know we're going to end up with an 8x squared. You know you're going to use the 1 and the 3 because that's obvious. Those are your only choices. Would you like to use 2x and 4x or 8x and x? Okay, let's use the 2x. Use 4x. So plus 1 and plus 3 or plus 3 and plus 1? Got to have plus 1 and plus 3. Here's why. I made a guess. Now I check. I know that the 2x and the 4x makes 8x squared. I know the 1 and the 3 make 3. But if I check the inside and the outside, that should give me the middle. What's 1 times 4x? 4x. 2x times 3? Those add to 10x. We got to check. You guys generally have good number sense, so you can move through that pretty quickly. Some people really struggle with that. So, okay. Now I'll show you the AC method. The AC method says you first take this A, this lead coefficient, and multiply it by C. I do it a little bit differently than she does, okay? And that's fine. I think you guys will follow along with it just fine. 2 times negative 4, negative 8. So I start by doing that. Can you factor that? Yeah. That factors, and I'm going to leave some space. Factors to what? Plus 8, minus 1. What number did we take out from the beginning problem? I put the 2 back in front. Now look. Is there a common factor between 2x and 1? No. There's no common factor here, is there? So I just write 2x minus 1. Is there a common factor between 2x and 8? What is it? 2. So I take out a 2. When you take out a 2, you're left with? That's all factors. It's gone. It's just gone. That's it. So I know that AC method is slightly different than what you saw, but still pretty good. Okay, we are quickly running out of time. We finished this in the rest of class, but let me just do difference of squares, and I'll give you your assignment. You can get through what you can get through. We'll finish up on Monday. So difference of 2 squares, last part here. What multiplies to 9x squared? We would have 3x and 3x. What multiplies to y to the 4th? Y squared, y squared. When you have difference of 2 squares, one is a plus, one is a minus. So for x to the 4th minus 1, what multiplies x to the 4th? So I have x squared and x squared. What multiplies to 1? What do you notice about that? Very good, Alexa. You can break down the x squared minus 1. Can you break down x squared plus 1? Sum of 2 squares never factors. Difference does. x minus 1, x plus 1, and then I attach my x squared plus 1, and that's it. We'll do this sum and difference 2 cubes and grouping on Monday, and I'll have to look to exactly see where we're headed. We'll try to give you some work time in class as well. I know you guys haven't had that this week, so your assignment. So this is what I gave to the other class. You do not, some of the stuff. If you have, sum or difference of cubes, you haven't gotten there yet. So you're not gonna. If you remember, great. If you don't, it's okay. We'll cover it on Monday. But here's the deal. So again, I picked kind of different sets of problems. You don't have to do this. This is optional. You don't have to do the challenge problems. If you're like, hey, I need to try some harder problems because this stuff is too easy for me, there's probably half dozen people in pre-calc where I know what we're doing is too easy for you. If you'd like to swap out a challenge problem for a regular problem, go ahead. 75 through 81 are harder. You might want to try something like that. If you want to do them all just because you really love math, yay, great, good job. But, make sure that you do a little bit of that work. For sure, make sure you get caught up on 1.2. And like I said, I'll try to get you guys some work time on Monday next week, okay? Have a good day. Enjoy Bryn's birthday. See you soon.